Hello, I'd like to welcome you to ELE 111, Internet of Things. My name is Gary Millett. I'm going to be your instructor for this semester, the fall 2021. And this is the first topic in this course, an introduction to the Internet of Things, or IoT. And so let's get going. The first thing we might want to do is, give you a definition of what the Internet of Things really is, but let's start a little bit differently by answering some questions first and taking a look at what goes on today with the internet. So, right now, if you did a search on the Internet of Things, a Google search that is, you get close to 6 billion hits. So the Internet of Things is something that's in the common vernacular at this point in time, and it's the buzzword of, say, the 2020s. So I like to think of the Internet of Things as being the next logical use of the Internet. We'll examine this shortly, but first let's look at today's Internet. So what are the uses of the Internet? If one considers the typical uses of the Internet by most people, it is to access information, or social media, or entertainment. It kind of depends who you are, which one of those three that I just mentioned is more predominant in your use of the Internet. I find it very useful as a faculty member to take and access information, and also to provide information to students. Some people just use the Internet for social media, and some people just use it for entertainment, things like YouTube and Netflix and things of that nature. So how about you students, Generation Z? And I don't want to include everyone in Generation Z, because there might be somebody older than 25, but nevertheless, Generation Z has been growing up with access to smartphones, sophisticated PCs, and other computer platforms, things like iPads and so forth, for all their lives. To them, this is natural. By the way, Generation Z ages today are between 5 and 25 years old. And of course, here's social media. This slide added another one, the next one, so let's take a look at the next one. A few more icons. Today, social media tends to be more popular with the younger generations. And I asked the question, how many of these symbols do you recognize? I think I recognize about 4 of them there, but some other people might recognize quite a few more than I do. So what about Generation Z and the Internet? So most of us older folks, and I'm including myself here, recall the days of not so fast Internet access. I'm not going to bring it back to dial-up, but not so available Internet access, and cell phones that did not access the Internet. The first cell phones you just used for making phone calls. That was 1G and 2G. Or you could actually access the Internet, but if you did, they were extremely slow, and access was expensive, relatively speaking. We had 2.5G and 3G as a start of when we could access the Internet with our smartphones, or back then we used to call them cell phones. So young people have very little knowledge of how the Internet has changed how people live, because they've been living it. But both Gen Z and the rest of us are in for another technological innovation that will further enhance almost every aspect of human endeavor and commerce. So I've got a couple here that you'll probably hopefully chuckle at. I call this then and now. You see the old black rotary dial phone there. That was a 1200 bit per second modem that you would take the handset and put it on top of the modem. They're museum pieces today, obviously. This is what graces my living room where I am right now. New Comcast Infinity cable modem at 200 megabits per second on the lower right. Xfinity X5, they call it. Another then and now. 1990s era IBM PC. So this is the PC that people had when the Internet first came into being. It looks like this woman is puzzled by something's going on. You see that the PC was a desktop. The display was an old CRT. You had a large keyboard and a printer on the left-hand side there. Now, today, finding desktop computers is a little more difficult, although we have a lot of them at stick. On the bottom right is a Intel NUC circa 2020, and that's about 4.5 by 4.5 inches, maybe 2.5 to maybe 2 to 2.5 inches tall, and this is what's happened. The electronics has been shrunken down so much we can put it in a box this small. And of course, then and now again, on the left-hand side, we have an old Motorola cell phone with a retractable antenna and a keypad. And it had a display, but you couldn't touch the display to do anything. And then on the bottom right-hand side here, we have modern Samsung Galaxy S21s. And of course, you have touchpad access with those, touch screen access. So what is this new innovation? Well, the Internet itself was a result of a convergence of several new technologies approximately 25 years ago. Those technologies were computer networking, digital communication, and the evolution of computers available to the masses, that is low-priced PCs. So hard to believe, but 25 years ago, computer networking was not that commonplace. Computers of one manufacturer could talk to maybe the computers of the same manufacturer, but an IBM computer could not talk to, say, a Digital Equipment Corporation computer. Digital communications was in its infancy, and it's a new technology that's just gotten better and better. And of course, the IBM PC basically started the revolution where we could take and have PCs for the masses. Certainly, the Internet has changed how we can live, work, learn, and play. So this next convergence is again driven by technologies that have continued to evolve. So this is a new paradigm for Internet use. With the ever-evolving technology of embedded controllers, wireless networking, smart sensor technology, and more recently, we have things called machine learning, we call that ML, and artificial intelligence, or AI. We can now use that Internet to enable electronic control applications that were not previously possible. And you might say, well, why is that? Well, it turns out that to control things electronically, you have to do it in real time. And some of the applications, it wasn't possible to do anything in real time. However, with Internet communications now, we can actually get close to that real-time control of devices or systems. So this gives rise to the IoT, the Internet of Things. Machines talking to machines, or what we call M2M. Today, there are more things connected to the Internet than there are people in the world. This is expected to increase exponentially as we go forward, changing the nature of Internet traffic. So this slide shows Internet of Things with all kinds of stuff connected to it. You see things like a stove on the bottom right. It looks like a refrigerator, a dishwasher there. Oh, the refrigerator's on the left. Looks like a smart bit wrist device on the top left, a wearable, microwave oven, a truck, light bulbs, coffee maker. All kinds of things can be connected to the Internet today. And to control these things, we need what we call human-machine interfaces, or HMIs. And it turns out this graphic shows, again, the same things were on the prior slide. It looks like, but it shows how we might talk to them. The Fitbit looks like an iPad, a PC, and our smartphone. So one more definition, and that would be, what is the IoT field technician? So one might ask, who will install, maintain, and upgrade various IoT systems? Also, what types of systems are we talking about? So IoT applications have been proposed for almost any type of human endeavor that can benefit from being made more efficient, more reliable, more secure, more safe, and eco-friendly. Now, this last statement doesn't preclude the use of IoT applications that until now were not technically possible, such as things like autonomous vehicles or e-healthcare or the smart grid. So, again, the IoT field technician will be the person responsible for the installation, upgrading, and the maintenance of these multidisciplinary systems. You know, if one talks or considers the OSI 7-layer reference model, we're talking about the lower layers, which include the transport, network, data link, and physical layer of this 7-layer model. So the IoT technician must be knowledgeable about these networking system concepts, as well as the application-specific physical devices that implement the control system. What has been industry's response to the Internet of Things? Well, if one watches any TV at all, and I got to qualify this, you watch network television where there's commercials, it is quite obvious that most of the major technology company players have realized their futures will depend on being exceedingly involved in the IoT marketplace. You know, if you do a search for IoT links on these companies' websites, it further reveals their interest level in this emerging technology. Many companies have online educational resources about the IoT. They have white papers, videos of potential applications, parts kits, and so forth. This is a slide that says Cisco touts the IoT. So you see the Cisco logo, and on the right-hand side, IoT. We'll talk more about that in a second. IBM has linked Watson and IoT. So this slide says a cognitive IoT will transform entire industries, and it shows IBM Watson IoT. Microsoft has an IoT, what we call Grove Kit, and if you take a look at that, it's got a display there. It's got some type of printed circuit board, which is the probably microprocessor and Arduino most likely. Got a lot of connector cables and various sensors and so forth. On the bottom lineup of sensors, you notice there's the second one in from the left. That's an ultrasonic sensor with two ultrasonic transducers there. Microsoft also has what's called an Azure platform, and that's their cloud presence. Intel, another big player in this, has an IoT platform. I'm not going to go over the details of this, but there's a logical definition of the Intel IoT platform, and you see on the right-hand side cloud management systems, and on the left-hand side we see the devices that might be controlled by the IoT. So this is the Intel IoT platform. It's Intel's reference model for IoT. Intel also has a new architecture / family for the IoT. So if you take a look at here, on this slide, you see on the left-hand side, for control sensors and edge devices, we have an Intel Quark processor. For gateways, mobile devices, and purpose-built application-specific hardware, we have the Intel Atom platform. Scalable and efficient computing performance, we have the Intel Core. It looks like i3, i5, and i7. And then for cloud data center and whatever HPC is, we have the Intel Xeon. If we take a look at AT&T, which is a telecommunications company, it has an IoT starter kit. And again, you might notice that it's got a board, a PC board, power supply, and some sensors there. Also, AT&T came out with a second generation IoT starter kit and an OBD2 kit. OBD2, you might know, is the onboard diagnostic system for cars. 2 is the second version of it. And of course, we have the Google Cloud. There's their logo for that. And we can't leave Amazon out. Amazon Cloud platform is AWS. So the question might be, what is Cisco's response to IoT education? Well, Cisco's been active in the IoT educational space through their Net Academy program, and we know that as the Cisco Networking Academy. And presently, Cisco has developed 4 online IoT-related courses. There's a course called Intro to IoT, IoT Fundamentals, Connecting Things, IoT Fundamentals Big Data and Analytics, and IoT Fundamentals Hackathon Playbook. This is a start by Cisco. However, this approach does not address a fundamental problem, and that is Cisco has always addressed IT applications. IT applications would be like business or enterprise applications, as opposed to something we'll talk about in a couple minutes, OT. So I guess we're here in a couple minutes. What is Cisco's IT response to OT applications? Well, Cisco's Networking Academy curriculum is always focused on business IT applications, and the coverage of the physical layer has dealt with hardware, things like switches and routers. and, Cat5 cabling and RJ45 connectors. Now, the vast majority of IoT applications deal with what is known as operational technology, or OT. These OT use cases tend to be discipline-specific. That is, you might have automation, healthcare, smart grid, autonomous vehicles, and so forth. And they are typically highly reliant on electronics-based technology. So this slide has got a picture on it, graphic on it, and a little bit of verbiage to the right. This is called Enabling Technologies of IoT. So this diagram indicates the enabling technologies of IoT. The center area of the diagram shows the complex application that is to be controlled. And this application is typically some type of electronics-based system, and it has a human interface. Sometimes we call that an MMI, as opposed to an HMI. Again, using software, embedded controllers and sensors and actuators, coupled with wired and wireless networking and complex signal processing technologies, one can design a system that can control geographically large and complex systems. And then using machine learning and AI, these systems can even evolve over time. So going back to the diagram here, we go to the top upper left-hand corner. One of the enabling technologies, complex analog and digital signal processing electronics, that feeds into the center complex interconnected electronic system. And notice, by the way, an arrow coming in on the left-hand side and going out on the right-hand side. So that shows like input to the complex electronic system and output from it. The top right-hand corner, we have enabling technologies of wired and wireless networking technologies. And I'm not going to talk about it too much more today, but in this presentation, the vast majority of Internet of Things devices will be connected wirelessly in the future. So wired networking technologies have some role in this, but mostly wireless networking technologies will implement the Internet of Things. The bottom right-hand corner, embedded controllers and sensors and actuators, another enabling technology. And on the bottom left-hand corner, software control and diagnostics and data fusion, another enabling technology. So what has Cisco's IT response to OT applications been? Well, they attempt to bridge the gap to these OT applications in the IoT Fundamentals course, which you'll be taking as you take this course. Connecting things is what they call that course, but falls woefully short of imparting any discipline-specific knowledge. That is, they just don't go into any detail. They use the typical approach of employing commonly available board-level controllers to connect to various generic things without imparting fundamental knowledge about the underlying principles that, say, a typical electronics technology student would know and would use to troubleshoot a problem. Very much a 30,000-foot view of what's going on with the physical layer. Interestingly enough, Cisco's packet tracer, which I believe now is version 8, now includes sensors and actuators. So this is a screenshot of a packet tracer and the work area used by Cisco's proprietary networking simulation software tool known as packet tracer. So you drag things into that work area and connect them. Again, more about Cisco's IT response to OT applications. Cisco also makes the assumption that one has the prerequisite knowledge base to take the various IoT courses that they offer. That is, that you have programming language expertise. That may or may not be the case for a lot of people. Of course, the Cisco curriculum is also only available to Cisco Networking Academy students, so there's limited available to these educational resources. Now, several colleges, including STCC, have started to offer IoT-related programs, but these are at the 4-year or graduate level. For those of us that deal with the physical world, Cisco's curriculum disappoints. And I say not surprisingly, that's kind of my opinion, because there is very little in it about the required power electronics needed to actually implement real-world applications. It's kind of interesting, again, that's their disconnect from the physical world. Embedded control by itself can supply the needed power to drive motors, can't rather supply the needed power to drive motors or power-hungry actuators. Industrial control ECU platforms with relays and power electronics do exist in the real world. Also, there are many times when analog signals must be conditioned before being converted to digital values. This is a fact which is basically ignored by Cisco. I mean, the devil's in the details, and Cisco doesn't know many of the details. So here's an example of a Cisco Packet Tracer Smart Home experiment. And again, this is just a new release Cisco IoT security course experiment. And you see a house there, broken out that you can look inside of it, and various things connected within the house, all through the internet. So again, they started to do some of this stuff, but again, it's really from a 30,000 foot level or view. What about other IoT initiatives? Well, I mentioned this earlier. Springfield Technical Community College, or STCC, was awarded a 3-year NSF ATA grant to address the lack of educational materials related to the IoT space. We have jump-started this initiative by offering a 1-year IoT certificate under the Computer Systems Engineering Technology, or CSET program, which most of you people are, enrolled in. This is a follow-up, or rather follow-on to our course ELE 111, Internet of Things, the course you're enrolled in, that we've been offering since 2015. And of course, this is a 3-credit course with associated 3-hour lab using Arduino boards. And we used to introduce the Raspberry Pi. I should change this slide. We're just going to deal with the Arduino boards this semester. Since we have a couple succeeding courses, it turns out that's where we'll introduce the Raspberry Pi as we go forward. So this is the IoT certificate. If you have any interest in this, it consists of the following: ELE 111 and ELE 111L, which is the lab for the Internet of Things; ELE 230, wireless networks; ELE 230L, lab for the wireless networks. You might have to take the biomedical wireless networks course as opposed to the ELE 230. We'll have to take a look and see what happens with that. ELE 128, Internet of Things Networking and Security, and the lab for that, ELE 128L. ELE 256, Internet of Things Design Project. CSE 150, Linux Command and Shell Programming, and CSE 160, Intro to Programming using Python. Those last classes you'll be taking certainly in the CSET program. Also, one of the following: CSE 172, Cloud Computing for the IoT, or ELE 168, Developing Things for the Internet of Things, and the lab for that course. Actually, since this slide was produced, we've added 2 courses. Well, actually, only one that's any different than the ones I've shown you here, and that is, I believe it's EET, Programmable Logic Controllers, and the lab associated with that. So here's the lab tools. This is a Arduino board. Of course, we're going to use a red board from SparkFun, but nevertheless, there's an Arduino board, and notice there's a power supply connector in the bottom right-hand corner of that. There's a USB connector on the, excuse me, not USB, but yeah, it's a USB connector on the silver box there in the top left, or excuse me, the far left, I guess I'll say. And then there's a couple of sockets that you can plug things into. Here's a Raspberry Pi 4 bundle, which you're not going to get to use this semester, but you will in the future. And here's a Raspberry Pi again. So that's it for this little presentation. Thank you.